Assalamu alaikum dear students. Welcome you all in my new lecture. Okay, that is this is basically session 3, and in this session we will basically analyzing the 2D frame, that is determinate frame. Okay, so let's start. We have a new example, and that example is you can see right on the screen. So basically you see, okay, you see that this is a 2D frame, clear, having 1 2 if I okay, so this is the frame, you know it has bay 1, bay 2. So this frame has 1 and 2 bay, and this will be its height. So we will develop, this height is 7 meter, and the bay width is now different. So we need, editing the grids. So let's see, we will develop this structure, this frame structure. Clear? So units are kilonewton, okay, and kilonewton meter. Clear? We can select this option as well as this option. Clear? So let using this option. We have two bay, number of stories we have 1, okay, and story height is, let's say we insert the maximum value 7 meter. The number of bays are 2, and let's say we edit the grids. Okay, select spacing, kilonewton meter be ensure. From A to B, bay width is 6 meter, but from B to C, you can see there, this is A, this is B, sorry, this is B, okay, and this is C. So from A to B, this is 6 meter, and from B to C, this is 8 meter. Clear? So this is 8 meter. Okay, now story heights are different. Okay, so therefore we need to insert, this is a kind of, 2-story structure. Okay, because you see that this is level 1, this is level 2, and this is level 3. Okay, so this is Z1, this is Z2, and this is Z3. Clear? So you know about this height, you must know about this height. So this height will be, the total height of the structure is 7 meter. So deduct this height, that is 4 meter. You will get this height, 7 minus 4 give you 3 meter. So the below story height, you can say this is 3, and the upper story height is 4 meter. So therefore we need to insert another story Z3. So there we will insert Z3. Okay, there we need Z3. Okay, and show. Clear? The first story from Z1 to Z2, that is 3 meter, but from Z2 to Z3 that is 4 meter and Z3 will be 0. Okay, so this is the way that how we edit the story heights. Okay, so let's see. Okay, now this is our required frame structure right now. In this we have to basically develop that structure. Clear? So now we develop this, this frame. We need to convert this frame into this shape right now. So we need to, we see the frame structure which we develop like in this shape. Clear? So we need to delete this one and we need to delete this lower story column. Okay, so therefore so therefore we need to delete this one, we need to delete this one, we need to delete this one. Clear? And we also need to delete this one and we also need to delete this one. Clear? This is the way that how we will develop a frame structure of our required which we required. Okay, so here we have, I think so, here we have a ruler support. Okay, and the next one is a hinge. This is hinge and this is ruler. Clear? So assign joint and this is ruler. Clear? This is a hinge. Okay, so now this is our required model of frame. Okay, now we need to assign the loads. Okay, at free end we have this much load, at point C we have this much, and at this much. So let's see, we select this joint and we assign first this load and then we assign this load and then we this load. Clear? So select this joint, assign joint load, force, make sure this equals to 0, modify, OK, kilonewton, axes are global, means the load is in gravity direction. Add with this. Now you need to apply the loading in z direction. Okay, so there you have, because our axis, you must know about your axis. Okay, so here you can see z axis in vertical direction, so therefore you need to apply the load in with a negative sign to apply the load in downward direction. So minus 20. Okay, and okay, this is the load. Now we have to assign load to this member. Clear? The one is 30 and the next is 40. We assign both loading. Let's see how we can do this. Assign frame loading and point loading. Make sure this will be equals to 0. This one kilonewton. This button should be on. Force, global, gravity. Okay, and there we use the spacing. At 0 distance we have, I think so, 30 kilonewton. Okay, but at the last end, that is, I think so that it is 8 meter, we have 40 kilonewton. Clear? Let's see. This is how we assign the loading. And at this member, which is 7 meter height, having a UDL of 12 kilonewton per meter. So this is the total Okay, now let's see how we assign it. Go to assign, frame load, distributed load. This should be 0 kilonewton. Press this button. Okay. Force. Here you need to select the appropriate direction, because now if you look to the direction of your loading right here and compare this with your global axis, so you see that this is your x axis, this is your z, and the y axis is perpendicular to your plane, to your screen. Okay, so therefore we need to apply the loading in x direction, because the load is parallel to x direction. So therefore we need to apply the loading in x direction, but x is positive in this direction, and this in this direction x is negative. So therefore we need to insert the value of load with a negative value. Clear? And the direction of the load will be x. So therefore we select x, and the loading will be minus 12 kilonewton per meter. So let's see. This is how we assign such type of loading. If you want to see the whole loading, press this display menu, select this one and select frame. OK and OK. So you see that these are your loadings. So we done here. We develop the frame model, assign the supports, assign the loads. OK, and the next step is to analyze the structure. Model, do not run, and run now. This is example number 30. Clear? I think so. This is example number 30. Yes, 29 is, this is 39. 30. Clear? Okay, let's see. We search out, we check the reactions. Okay, because we have only reactions, not shear force and bending moment diagram. So AY is basically 102 kilonewton. Okay, AY, this one, this is 102, BX 84, and this is 11.81. Let's see. Join. Okay, so we done. Okay, and the results are okay. The results are accurate, 101 and 100% accurate. You see this value. This is, this is 101.75. Okay, so this is kilonewton. Okay, this is 84 and this is 11.75. So we done here 100% okay. Clear? The results are 100% satisfied. And if you are interested in shear force bending moment diagram, this will be your shear force diagram. The maximum shear is there. Okay, if you are interested in bending moment diagram, you can see this one. You can bring the cursor on the member and click the right button of your mouse or your keypad. This is the loading diagram for this column member. Okay, and they are the shear force and bending moment and deflection. Clear? So you can examine one by one each. Okay, this is the point of inflection, and you can look at the distance from just clicking your right button of your mouse and scrolling this line and adjust it at the point where the bending moments comes out to be 0. Okay, so you see that this is the point where the bending moments approximately equals to 0, and you see that the point of inflection from this support lies at a distance of 2.33 kilonewton. So this is the point of inflection, this is the point of inflection, and this point lies from this support at a distance of 2.34 meter roundabout. Okay. Now we done here. Okay, this is the analysis of this frame. Okay, and this is the end of this lecture. If you have any question, please share your question, your comments on my YouTube channel, on my contacts. Watch the video and enjoy. Thank you.